Hello everyone, and welcome to Predictive Analytics, the traditional methods and techniques and tools. In this video, what we're going to do is we're going to review what predictive analytics is all about. Okay, we'll talk about some of the traditional methods. You'll find that we have two different methods. One is traditional and one's going to be machine learning. We'll talk about both of those traditional methods in this video, machine learning in other videos. And then we'll kind of look at some of the tools that are used in the traditional method. Okay, so for the most part, going back to our illustration here that we've been following throughout the majority of the course, we're talking about this now, the analytics, the future, I should say, of analytics. So far, the last video, we talked about business intelligence, which dealt with the past and all the data collected in the past. Now we're going to talk about trying to predict that future. Predictive analytics is actually the term for it. When we look at predictive analytics, once again, you'll see traditional methods and machine learning. We'll talk about some of the techniques in each of them as we get through it, and then also some of the tools as we kind of walk into this, okay? Again, with this particular video, we're going to focus on the traditional side. So what is predictive analytics? Okay, now that we kind of looked at, business intelligence, we more analyze, that term analyze the past, right? Now what we want to do is look into the future, try to take that same data, using that data in a sense, and try to predict the future in this case. So we'll take the information that we had and we get analytics on it to predict that future, okay? You can almost imagine the power of that, right? So if we can predict the future, what can we do with that? What can we do in relation to the stock market, the weather, and so on? And yes, matter of fact, I read an article not too awfully long ago talking about how AI is helping us really predict what the stock market's going to do. That's a really interesting concept, isn't it? So with that, we're leaving analysis and we're going to analytics. Hopefully everybody understands that. The analytics really deals with the future. All right, so for this particular video, kind of repeating myself a little bit here, I apologize, but make sure we're going to focus on the traditional methods. There's two different methods here. Traditionally, which really deals with statistical formulas. So statistics, okay, and all the formulas associated with that. So, and then basically machine learning is all about AI, basically, artificial intelligence. So we're going to focus on this one right here, okay? Our goal in doing so is going to be really kind of focusing on the different types of statistical methods that can be used. I don't find this to be an exhaustive list. There's all kinds of statistical methods that you can learn and actually utilize to probably, try to figure out what the future holds. I did a lot of statistics. I've taken many statistical classes, did a lot of statistics in my PhD work, doing quantitative type research. You may have done that in your classes or high school or higher level, whatever. Same type of concept where we're basically proving a hypothesis. This is sort of the same thing. We're going to be using the data that we have to kind of prove something and try to figure out what the future holds for it. This particular chart looks at regression, logical regression, clustering, factor analysis, and time series. We'll talk about each one of these. My goal here is not to teach you how to do this statistically. This is not a statistics class. My goal here is to show you some of the different techniques that are used, the methods that are used. And again, if this is of interest to you, your goal should be to go get that education, a statistical class, and actually more information on how to perform all of these in a data science type role. All right. So traditional methods uses advanced statistical techniques to try and determine future scenarios. We talked about that. There is no one technique, and the ones we will discuss is not exhaustive. But we'll look at each for the sake of a great example. Later we'll see how they were used in some real scenarios as we walk through it, okay? So there we go, regression. We'll start with regression analysis. In statistical modeling, regression analysis is a set of statistical processes for estimating the relationships between a dependent variable and one or more independent variables. Well, if you're not a statistical guru, that might look like, what are you talking about? So basically what we're going to do is take a variable and compare it. What's a variable? Well, think about that from your programming piece. It's a piece of data, and then looking at it from another piece of data. Can that data change? Of course it can. That's what a variable is. So your definition of a variable from a programming point of view should be the same as it is in this case. The purpose of regression analysis is to predict an outcome based on historical data. So we basically look at everything that we have, and based upon some formulas and statistical methods and formulas, we can actually try to predict what the future holds. It's actually pretty neat. Let's kind of look at it. So example, if we want to predict what type of people buy wine, I would find data on people who buy wine, their age, height, financial status, etc. So analyzing this data, I can build a model to predict whether a person would buy wine or not. So regression analysis is used to predict the behavior of a dependent variable, people who buy wine, that's a dependent variable, based on the behavior of a few or large number set of independent variables. That's the age, height, and financial status. So who are the people that buy wine? That's dependent variable, and then the independent variable is age, height, and financial status. Once again, if you're listening to this going, what the heck's he saying? I'm not following this. This is for information only. I am not going to ask you to do regression analysis in any assignment. You're just basically understanding that how this kind of works. Another example. So global warming may be reducing average snowfall in your town, and you were asked to predict how much snow you think will fall in the future. Looking at the table, you might guess somewhere around 10 to 20 inches. That'd be a good guess, but you could make a better guess by using regression. So we can kind of look at this particular piece, this particular table I found online from years 2000 to 2013, and we can kind of, look and see what it's doing and trying to find a trend to it. Or we can use regression analysis, which has formulas associated with it statistically to help us with this, okay? What we usually do is regression is the best guess at using a set of data to make some kind of prediction. It's fitting a set of points on a graph. So we would look at a graph based upon 2000, where you see the amount of inches, okay, and in each one of them. What we usually do is this linear piece. This is where we basically kind of draw this linear line to try to see where all these are plotted and trying to find a commonality to be able to actually determine what the future may hold. In this case, 2015, 16, and so on. All right. Just by looking at the regression line running down through the data, you can tune your best guess a bit. Again, best guess. You can see that the original guess, 20 inches or so, was probably way off. For 2015, it looks like the line will be somewhere between 5 and 10 inches. So if we actually continued on with this line, if I can find my cursor, and kind of cut down here, if that line kind of keeps going with it, we'd probably be right around that 5 and 10 inch mark right there for 2015. Because we plotted all of these, this is where it came up to, okay? That might be good enough, but regression also gives you a useful equation, which is y equals bx. And you might be saying, what the heck? Let's just kind of look at it. Y equals bx. This equation is kind of cool, where y is a certain number based upon statistics that we actually figure out, and we can actually plot in. This number right here comes from the statistical formula based upon everything that's been plotted before. It's determined this y variance, and we can actually plug in the year. It's actually then gives us as a number 4624. You might ask where it comes from. Once again, it comes from the statistical method based upon all the previous data we had that will actually come up with and give us a pretty good indication of what we're actually seeing here. So you can literally plug in this stuff. So in 2005, using this formula, 28.3385 inches. So let's go back to 2005, kind of come up here to see where we are in this case, and right around here, which is basically pretty darn close to the 30 inches that we kind of see for that year. Best of all, you can use it for statistics. So this equation actually works for just about everything we plotted. We can then go ahead and look at the future and put it in 2017 using this formula, and we're going to come up with less than an inch. So if we look at this linear line and kept going out, based upon the history, that's what regression analysis is all about. Pretty cool, okay? It also gives you an R-squared value. I don't know if anybody here is taking statistics or not, but if you have, statistically, it's a probability type thing, right? The statistics gives you, here it is, but then how good is it? There's usually this R factor that might be in there that basically tells you how good your graph is. If something's close to 0, it's not a really good model. Something's close to 1, it's a perfect model. In this case, this model was 0.702. So for the most part, it's a pretty good model, and this modeling basically tells us that that our prediction is not too bad. Once again, it's a prediction. And like with all predictions, a lot of other variables could come into play that would make things, a little bit different. All right, so once again, this is regression analysis. So people use this type of statistical method to predict the future, okay? Again, just for more information, that's what it is, okay? Logical regression analysis is an appropriate regression analysis to conduct when the dependent variable is, oh my gosh, dichotomous. I should have figured that out. Binary, yes or no, okay? Like all regression analysis, the logistic regression is predictive analysis. Logistic regression is used to describe data and to explain the relationship between one dependent binary variable and one or more nominal ordinal, interval, and ratio level independent variables. No, I did not write that. I went out to the internet and got that for you, but you can kind of see it. Types of questions. How does the probability of getting lung cancer, yes or no, that's the yes or no binary piece, change for every additional pound a person is overweight and for every pack of cigarettes smoked per day? So if I wanted to come up with some statistical method to determine this, we could probably predict if somebody's going to get lung cancer based upon their weight and their packs of cigarettes they smoke each day. Does that sort of make sense? Do body weight, calorie intake, fat intake, and age have an influence on the probability of a heart attack? Yes or no? Heart attack is yes or no based upon all those pieces. So when they plot all that data, we can kind of figure out what the future holds. Does this make sense what we're doing? We're just looking at a couple of statistical methods, and basically these can help us predict the future based upon this data. And so if a company has a bunch of data and we're looking at things, yes or no, that's just one of the methods we could use. Clustering. Cluster analysis is a task of grouping a set of objects in such a way that objects in the same group, called a cluster, are more similar to each other than those in other clusters. So in this case here, we would look at data. So cluster analysis is a task of grouping a set. Okay, so we would look at data and we would plot it all. But what we could do with this data is a regression analysis and try to find a line. But what we might be able to do is when we see all this plotting, we see that certain things are clustered. I know the colors in this particular slide lends itself to that, but those clusters could actually mean something to us. So statisticians and data scientists would look at those clusters to see if there's a trend that could tell us something, okay? And so in doing so, if we sat back and looked at this particular scenario, where we have a user experience, okay, where we sit back and say there's customer revenue based upon the customer revenue, okay, and the customer satisfaction. We would plot all that information. And then what we can do is go in and go a little bit deeper. We can do a regression analysis, okay, with a line, or we can see these clusters and try to analyze them. And maybe what we start finding out is this cluster is from Asia, this cluster is from North America, this cluster is from South America, this cluster is from Europe. What can we predict? Well, maybe we can start predicting that if somebody is from North America, based upon their customer revenue and their customer satisfaction, they have this type of user experience in South America and so on. So in this case, what we're basically looking at is, are there clusters and is there more variables to this that actually defines what we're actually looking at? And we can probably do some predictions based upon some of those variables. All right. Factor analysis. Factor analysis is a statistical method used to describe variability among observed correlated variables in terms of potentially lower number of unobserved variables called factors. For example, it's possible that variations in 6 unobserved variables mainly reflect the variation in 2 unobserved variables. That's factor analysis, okay? It allows researchers to investigate concepts that are not easily measured directly by collapsing a large number of variables into a few interpretable underlying factors. And so that one, okay? So in this case here, The key concept of factor analysis is that multiple observed variables have similar patterns. So here's the variables. It could have similar patterns. And so, for example, people might respond similar to a question about income, education, and occupation, which are all associated with latent variable socioeconomic status. And so the factors are factor A, factor B, and this come about income and education and occupation, but the variables could be their socioeconomic status and how they reflect on that. Pretty deep stuff there, okay? Time series, pretty easy. Time series comprises methods for analyzing time series data in order to extract meaningful statistics and other characteristics of data. Time series forecasting is the use of a model to predict futures based upon that. What would you think time series would be used for? I mean, in this example here, examples include a continuous monitoring of a person's heart rate. I guess you can monitor your heart rate to figure out when it's going to stop at some point in time. Hourly readings of air temperature, company stock, monthly rainfall data, and so on. We basically analyze and take, a continuous monitoring of all of those to try to predict the future and where it's going to go. Kind of makes sense, right? A lot of statistical formulas around this and methods to actually try to predict this. All right. Whew, what do you think so far? Again, I want to make sure, and I'm finding myself a little bit uneasy, that you understand what we're trying to accomplish here. For the most part, all we're trying to accomplish as we walk through these slides, I'm going backwards now, is really a decent understanding or a high-level understanding that statistics plays a huge role in the traditional methods of predicting the future, okay? So you must have a good education in statistics. And again, I didn't want to bore you with all the details of each one of these, but my goal was to demonstrate some of the statistical methods used in your understanding. And again, if it piques your interest, go get further education. Okay? So I'm going to go back through here again. And some of the, oh, we're not there yet. Here we go, almost. Probably some of the tools that were there, but go back here, as you kind of see here, some of the programming languages is R. We've already talked about that. Python is in there still. MATLAB. We get into some eViews and Stata, and here I have this here. eViews is a statistical package for Windows. Stata is a general purpose statistical software package. These are packages that will help us perform these statistical methods, okay, by putting data in and then running those different pieces. I've used different ones of these, again, more in my PhD work to be able to prove theories and hypotheses and so on. It's kind of neat how they work. You just tell it which formula you want, what statistical method you want to use, and you provide the data to it, and the results pop out. It's pretty cool and pretty neat how the whole thing works, okay? And so, in a sense, that is predictive analysis from a traditional method approach, okay? Hopefully not too hard. Again, more informational than it is. I highly recommend that you go out to the resources provided in the course and take a look at those. I kind of labeled them all through so you can actually walk through them, go look at some of the other definitions for all this. I guess get a decent idea what this is all about. All right, so there you go. Next thing we'll talk about is machine language.